Today's video is on page 6 in your 1D Intro to Proportional Thinking packet. This is one place or another place where we see that you can use proportions to solve for an unknown value. It's called similar figures. Similar figures say that the corresponding, the matching angles, so the upper left angle matches the upper left angle here, they're 90 degrees. The upper right angle matches the upper right angle. That's what corresponding is. They're matching positions. The lower right matches the lower right, and the lower left matches, they're all 90 degrees. They are equivalent. So their corresponding angles and their corresponding sides are in proportion. So I'm going to add that on. That's the definition of similar. Some teachers will say, oh, they're the same shape but different sizes. I don't really like that definition. I like that they have corresponding angles that are congruent. Corresponding angles that are congruent. That's the congruent symbol, which means they're exactly equal in measure, and their corresponding, their matching sides form a proportion. They are proportional. Corresponding sides are proportional. So I would like you to add this on your notes today. The definition of similar. Corresponding angles are congruent and corresponding sides are proportional. It's called similar figures. So here's an example. Winifred has a large rectangular garden, but Zuli has a similar, smaller garden. If the length of Winifred's garden is 35 feet, what is the length of Zuli's garden? So we can see that we have 3 numbers in our 2 pictures and a question mark. 4 things. So those 4 things can be set up into a proportion. You know that you can write a proportion for the corresponding sides of similar figures. The length of Winifred's garden over the width of Winifred's garden. So 35 over 20, as you see here. 35 over 20 does correspond to the length of Zuli's garden. Oh, N, X, K, Q, whatever letter I want to use there, over the width of Zuli's garden. So it's length over width equals length over width. And I like to write the word ratio next to it to make sure that I'm consistent in putting in my mathematical numbers so that it is like an analogy in English that they are in corresponding positions. It's mathematically logical. So 20, we know the product of the means. 20 times that n has to equal the product of the extremes, 35 times 16. So 20 n's equals 560. Dividing by 20 on both sides, you get n is 28. So here's the Sable. The length of Zuli's garden is 28 feet. That's a word problem with a full sentence answer. These problems are just pictures. They're not word problems, so I'm not going to give them a full sentence answer, but I am going to find the missing value. So number 1, I could set up number 1 as width over length. So I kind of like draw this arrow that reminds me, oh, I'm putting the width on the top over length x has to equal, so width over length has to equal width over length. I could set it up that way. Oh, 10, not L. I could also set it up as width over width, 2 over 4. I could set it up this way. I would get the same cross products. Width over width, so little width over big width, will equal little length over big length. And you can see that I'm going to multiply 2 times 10 and 4 times x. I could set it up actually 4 different ways. This is just the way that I did it. The first blank here is for your proportion. So 2 is to x, width is to length, as width is to length. And solving it, 4 times x, the product of the means equals the product of the extremes. 2 times 10 is 20. So when I divide by 4, I know that that x has to equal 5. And this is geometry, so we need to make sure we put labels on it. And the label is feet, so 5 feet. Number 2, we have similar triangles here. So I could say that right side, that 3-inch, over right side, n, has to equal bottom side, 8, over bottom side, 24. I could also set it up a second way and say 3 over 8, so right side over bottom, 3 over 8 could equal right side over bottom and over 24. And yes, I'm going to multiply 3 times 24 and 8 times n. You can see that it will work the exact same way. So that's just 2 of the ways. You could set it up 4 ways. I'm going to multiply my 8 times my n, the product of the means, has to equal the product of the extremes, and 3 times 24 gives me 72, so 8 times what number equals 72? Well, we all know that. If I divide by 8, right? If I divide by 8, we know that that n is going to equal 9. And it is 9 inches. Number 9 here. Doesn't have the blanks with it, but I'm going to do number 9. So 4 over 3. So top side over top side, a couple parallelograms. So top over top. So big one over little one. I could even say that, big top over little top. Has to equal big width here, so big width, which is B, that's the big width, over the little width, 2. So that's corresponding sides way of setting up my proportion. 4 is to 3 as B is to 2. And I like to draw those arrows when I'm looking it over to see, ooh, did I follow the same order? Because if you oops and you say 4 is to 3 as 2 is to B, well, that's not logically, mathematically equivalent. It's not consistent. 3 times B has to equal 4 times 2, the product of the extremes, which is 8. And then when I divide by 3, I'm going to get B equals 2 and 2/3, or if you put it into the calculator, you're going to get that repetent 6/10. That you have to put the word units or unit, 2 6/10 units. Some kids like to just abbreviate that with the little u. We're going to finish this riddle in class tomorrow. So that's it for today's video.